Now we come to a question which asks you which of the complexes is diamagnetic or paramagnetic. So it gives you complexes from K to P, K, L, M, N, O, P, and gives you options and asks you which of these are diamagnetic complex. So first let's check for K, if K is a diamagnetic or a paramagnetic complex. So K is K3 FeCN6. So first of all we need to find the oxidation number of iron here. So that will be 3 plus x minus 6 will be equal to 0. So that means x is equal to plus 3. That is going to be the oxidation state of iron. So that means iron is going to exist as Fe3 positive, and if iron is going to exist as Fe3 positive, it means it has 5 electrons in the d orbital. Five electrons in the d orbital. Okay, now with iron, Cn is present as a ligand. Cn, what it does is, to make empty orbitals, it can pair up the electrons present on the d orbitals, that is the 3d orbital. So this electron is going to pair up and this electron is going to pair up. So we will get 1, 2, 3, 4 and 5. Even if the electrons are getting paired up, as you can see, still one electron is still getting remaining unpaired. If the electrons of the Cn negative ligand come, they will come in these orbitals. Okay, then there is going to be S and then there is going to be P also. So the electrons are going to come into these, but still one electron is remaining unpaired. That means it is not a diamagnetic complex, it is a paramagnetic complex. So straight away we can say that options A and option B are incorrect because both of them contain K. So we can do a comparison on the basis of option C and D. Now in option C and D, L is present, M is present, as well as O is present. So the difference is between P and N. We can only check for P and N, we can determine which of these options are correct. We do not need to do for entire complexes. That is how you save time in these complexes. Do not start doing for all of the complexes from K to P. Check for what you need to do. In both of the options C and D, L is present, M is also present, O is also present. So that means either it's going to be N or it's going to be P, which is a diamagnetic or paramagnetic. You can differentiate on the basis of that. So let's take with N first. N is this, Ni so Ni H2O whole 6 Cl2. So two Cl ligands are present outside. That gives the coordination complex a charge of 2 positive. And if the coordination complex has a charge of 2 positive, that means Ni is also present as a 2 positive ion because H2 is a neutral ligand. So that means the electrons in case of Ni are 8, 3d8. Six, 7 and 8. This is an octahedral complex, you can see that. So we need at least 2 orbitals on a 2 empty orbitals in a d subshell. Okay, even if we are going to pair up, that is not going to happen. So pairing does not take place and the electrons of the H2O, they come into the other empty orbitals, that is S, P3 and D2. So it's an outer orbital complex. Okay, so it's an outer orbital complex. That's a 4d, and out of the 4d only 2d orbitals are used. So this is sp3d, and you can see that 2 electrons are unpaired. So that is paramagnetic. So that means N is paramagnetic. So this option is also incorrect. So that leaves us with option C. So the option C is our correct option. That is complex L, complex M, complex O and complex P have no unpaired electrons and all of them are diamagnetic.